we are now officially covering something called Docker Compose. If you haven't already, read the Docker Compose stuff. So I want to explain what Docker is. Docker is essentially, it was created for testing environments for developers, but now users use it because it's been out a lot. A lot of people have been working with it. And what it essentially is instead of Docker Compose or Docker, let's just pretend it's called Sandbox. That's all Docker is. It's a glorified way to sandbox essentially applications. So there's something called Docker Hub, right? There's something called Docker Hub that houses images of applications, okay? So this is my personal one. But essentially what you can do is you can explore Docker images. And let's say, oh, I want to install Nginx really quickly. So Docker pull Nginx, you look at the tags and you just can grab either develop, latest, stable, bullseye, bullseye, Perl, bookworm, Perl. I think bookworm is mine. So, but apparently you could just grab the latest. Or, you could do it that way. But Docker is essentially containers, and it allows you to start, stop, and rebuild services, view the status of services. And in unRAID, you have these containers and, plugins, community applications, all this stuff. But again, you don't want to get used to that. So we're going to cover Docker. And basically the way Docker works is you create a folder. Okay, you create a Docker Compose file. In this case, they're doing something with Python. They're defining a base image with this from command. A base image is from Docker Hub, which is this kind of portal. It's kind of like GitHub, but you have like little tags called latest, bullseye, stable bookworm, which is my current install, the latest, Debian. And then it essentially you create a compose file .yaml. It creates services, and the ports, think of Docker this way. Docker is one big sandbox, and you can run the sandbox with a command line command, right? Or you could do Docker Compose, which it runs that same command line command, but for all the settings, you reference these sort of, these settings right here, services. And these services, web and Redis, notice the spacing. It's very important. So you use something called Visual Studio with the indent rainbow plugin. See what's going on there? The rainbows and all this cool stuff. And you want to do that because it really allows you to track the spacing. If your spacing is wrong, it could literally mess up the Docker from running. So you run it, and one thing is the ports. We're going to talk about networking, but again, remember the left side is the host, the right side is the container. So think of Docker like one big sandbox, okay? And things run inside the sandbox. So here in this image, I have two things here. I have a local host right here. This was my setup with all the star apps from Swizen. And then you have a container, okay? Now, usually Docker was used for development reasons, but people will use it for production because, where there's a lazier way, people really want to do that. And I don't blame them. It's convenient. But really, let's pretend that for right now, these plugins, Sonar, Radar, all these things, they were inside of this container like this. Each compose file defines an image, right, and a service. So in my example here, where these two would be inside of the container, right, you would have a compose file called overseer here, radar here, sonar here, just like this, plex, sonar, radar, LiDAR, and then you would define options, right, for them. What image do I grab this service from? Things like that. So, even though there's a base image here in this case, but sometimes I think I don't really know about Docker file, but I focus on this one, Docker Compose, because that's all for the user. I think that's more important. So when containers are created in the same Docker Compose file, they're all in a container, meaning each container gets a virtual router, right, with an IPv4 gateway. And these, whatever the names of the containers are right here, they're like the domain name service, right? So you know how a .com links to an IP address, but you don't have to type the IP address, right? Even though you're exposing the IP to the internet so that the website can see it. But these allow you to use host names, okay? So, in this case, the host name would be, for example, for web and, all that is, we'll cover this later when we're talking about the networking, but all you do is you go Docker Compose up, it creates it, right? And it creates something called a temporary storage area for the application data. Every time you stop the Docker Compose by going Docker Compose down, it deletes that area. So what people have done is they created something called volumes, which is like a mount point, right? The left would be the host directory. The right would be what you want the application to think is mounted. So /code here, let's say it would be mounted to /home, /user, /whatever folder. So these allow you to create, this mode should only be used in development, but people are using it in production. But this allows you to create what's called persistent data. Persistent data means it doesn't just disappear the minute the Docker or the sandbox is destroyed, right, or closed or stopped. So people started using it, right, to install and manage their servers. They got the star apps on Docker and all this stuff. But remember, the star apps don't want you to run Docker. They want bare metal, which is what Swizzen allows you to do. But Docker Compose up, and again, here we're talking about shared folders, volumes, and bind mounts, all this stuff. Really read this stuff, guys. And again, Docker Compose up D, Docker Compose PS shows the process, list, all this stuff. Docker Compose stop, Docker Compose down. You can bring everything down, removing the containers entirely with the down command. Pass volumes to also remove the data volume used by the container, because otherwise it doesn't remove it, because that volumes is used for persistent data you want to keep. So Docker is essentially a way to like quickly bring up programs and quickly stop them and destroy them. And really, it's people use it kind of like as an all-in-one solution. But the problem was when I was doing it and I was getting into more complex stuff, things weren't working. And remember, people can set their own settings. Like for Plex Meta Manager here, for example, someone did, all these container variables. So there's container variables. There's a container and these are, if I hit edit, you could see, this is a variable with the name time to run, with a key PMM time. So these are like defined by the program people, right? PMM libraries, these are the container, this is what we want the variable to be, etc. So this is all defined by Plex Meta Manager, for example. Or in the case of Plex Image Cleanup, this was manually done. There's no app for this, but maybe I can update one, I don't know. But again, so this is a personal thing where it says, this is a path, config. I want it to go here on my personal, thing, and I described it, and then you can see here all this stuff. So it's very handy to have a GUI, but again, you don't really want that. And there's something just like, again, we're using unRAID or Ubuntu, but there's something that they have for just bare metal Debian as well, where it's called Portainer. We're not going to cover it, but this Portainer will be later. But this is something you can use as a GUI, but you still want to manually execute everything. All the Docker Compose files, manual. There is something where they have this thing called app templates, but a lot of them may not be good. They may not really match the Docker Compose. These applications want or that might work for your system. So never just install, I don't like doing it. And a lot of these are just containers. Stack is better because then you could see you can actually see. So for Bookstack, for example, if I were to do it, right, copy as custom, you see that? Boom. So if I copy as custom, I can see the Docker compose. This is what you want. You don't want just the container and it does, all this crazy stuff by itself. So I never do app templates in Portainer. But let's talk about networking, because that was something I didn't really realize with Docker. Whenever you create something from a compose.yml called my app, Docker creates a default network, okay? My app default, okay? Which basically means anything that's inside of the container, they can reference each other by just their container name. So let's say it's Radar said, hey, or Overseer does say add Radar, you would just reference it in the HTTP. You would just put http://radar, literally the name, because they're in a container with, and they can reference each other's host names. So it is important to note the distinction between host port and container port. In the above example, the host port is 8001 and the container port is 5432, right? So network service-to-service communication uses container port. When host port is defined, the service is accessible outside the swarm. What this is just saying is that, listen, the container might think it's listening on 5432 because that's how, it defines the image. And you never, ever really want to change the right side. You don't want to change that. I haven't attempted to change it, and you might actually be able to, but you could, I think. I'm not sure, but I don't touch it because I think it's defined by the image. I might be horribly wrong, but really what your machine is seeing is 8001. So if you were to do 192.168.1.8/8001, the container thinks you're really doing 0.1.8:5432, which isn't true. Now, one of the things is that the biggest things that happened was I had my sonar and radar outside. Let's pretend this red box is the machine, right? That the container is inside of, indicated by this red arrow, this one. So Overseer is not allowed, okay? It is not allowed. I'm going to do a big X here. It's not allowed to go outside the container. Remember, it's a sandbox. So in order to do that, and this is where I kept getting lost because I kept doing 192.168.1.84/radar. I was referencing the local machine, local host, nothing was working. The Overseer logs, and that's another thing. Whenever you're running Docker, always check the freaking logs. The logs were saying connection refused, connection refused, connection refused, which means error connection refused pretty much means there's an issue. It's not a valid IP address, which is the worst kind of error. Because you know that the IP address is freaking valid. You can go to 192.168.1.84/radar and you'll see it. In my case, Overseer was not seeing it. And it's because there was not something in there. So this is the Overseer. Let's go to the Overseer compose file. So again, for every compose file, you want to define a volume that makes it persistent. Here I put it in a network called pre-created network with Docker's like command line called proxy. And then this is just telling it, hey, don't create another one. So if you do external and you just leave it blank, it won't create it. It thinks you want it to join one because it's already there. So restart unless stopped, always do that. And you can see it defines the user ID and group ID here and the environments folder. And one thing I want to say is remember the environment variables, when you're using Portainer, they must be inside of here. That's the negative with Portainer, but you get all this amazing GUI stuff. But unless I think you define it here as a env file, then maybe, then maybe it might be able to do it. I haven't attempted load variables, but I think then it just, see, to reference the env file in your compose file, use stack.env. So you can't really even reference /mount because it's only looking inside of the container. So it even keeps this file inside of the container. So it's not even referencing the app data. So I remember doing env in the app data, and then Overseer was like, it wasn't Overseer, it was actually Traffic complaining about token and stuff like that. Traffic is a reverse proxy that we'll talk about later. But the key thing to know about containers is that things inside of the container can see each other, but the container can never, ever see outside into the host machine. Never. Unless you put extra hosts, and then you put something like, and again, remember, this is a YAML file or YML file. You want to really create these distinctions. Host Docker internal equals host.gateway. This is a crucial command. This will allow you to see the IPv4 gateway. Notice how I have these IP addresses, 172.10.0.3. Let's pretend Sonar would be 0.1, Radar's 0.2. The reason I use Portainer, and keep this in mind, is, let's open a new image here, is that once you create, there's two types of drivers, bridge and host. Bridge just means anything inside of that container's network can bridge to itself. So applications running in the same network can bridge. They can reference each other by name instead of by IP. But when you do host Docker internal host gateway, you're basically saying, okay, let my host network interface suddenly see the host gateway, which means, and the host gateway is a synonym for 192.168.1.8 for the local host of the machine. So even if you were to suddenly type on Overseer add radar 192.168.1.8, it's not going to work. You have to put host Docker internal, which is the domain name here. Okay, not host gateway, host Docker internal. Or you have to put this IP address, and then it will start seeing the radar outside of the container. This is something that I spent days on before I figured it out. You could see right here at the top, version 19. Look at that. I went through 19 revisions before I found the magic ingredient. So I'm saving you guys days here of agony. So host.gateway is a special Debian Ubuntu created variable, Docker variable, that allows Docker to see the map of essentially the host. It can suddenly start seeing all these zeros and localhost 7878. It can see that now. So that's a huge thing about the networking. Huge. And of course, one of the things we will talk about is that once you do this and you reference radar from the Docker, you can't use SSL from Overseer because it when it tries to connect to radar as the local host right here, radar sends it fake SSL certs. It says, hey, look, I have certifications from Snake Oil. Overseer doesn't like that because Overseer has something called TLS checking or authentication. Some apps do it, some apps don't. Some apps even let you skip it with an option. Like a reverse proxy option like Traffic lets you skip it for certain things. But alas, here we are. So I do Cloudflare. So for me, I had to reference the Cloudflare name and then even though I gave it, the radar URL, it was then able to go past that whole, oh, this is a self-signed certificate. So that's just the light point that I want to make here. Just a very light point about that. So again, this is Overseer. And okay, so here you can really see the radar configuration on Overseer. Notice I'm referencing swizzen.domain.com. That's how I set it up. And swizzen.domain.com 443 with the URL base of radar always leads to radar. So I didn't give radar its own domain. I could have done it that way and then I think left a URL base alone, but I didn't do it that way. So I just wanted to touch that lightly. Anyways, guys, so that's a huge introduction to Docker as it relates to media servers and Swizzen. Again, you really want to realize that containers are sandboxes. And when things are inside of them, they can only reference each other under the, same container.